Hello everyone, welcome to our video on using the chain rule. So the chain rule is used on compositions of functions. So when we have functions inside of functions, to make something that is complicated into something that is easier to work with. And what we have is these, so all of these are the chain rule just written in different ways. I usually use this bottom one for my notation. Okay, and all it is just showing that if you have a function inside of a function, like let's do the second star too. So I like the bottom starred, but what it's saying here, so the derivative of f of g of x, so g of x is inside the function f, is to do the derivative of this f function, this whole big giant f function, times it by the derivative of your inner function. Okay, so that's how we're going to break it down. All right, so, and here's our process for it. I'm going to go ahead and we'll do it and reference back as we go. So in this example number one, we can use the chain rule. We'll also check it using another method. But to use the chain rule, what we're going to do is state that I want this expression. So usually we use the chain rule on some expression that's raised to a power like this, is where we'll set our u equal to that expression. And then once we decide on what u is, we'll instantly go ahead and get its derivative with respect to whatever letters on the right. So we'll do du dx. The derivative of 2x plus 1 would be just 2. Okay, and so what we're going to do is rewrite this expression, the y equals, so that in the blue is still u, and it's still squared. And so now it's just a real basic function where we could just use the power rule. So we'll do the derivative of y with respect to x. So it's still with respect to the original letter there, the dy dx, is equal to, all right, so the derivative of this is now, it's just the power rule that we'll use. So the 2 would come to the front, and then u, and then minus 1. But the main thing is, well, if we change the letter, so we went from x to u's, we just have to make sure we multiply it by the end by the derivative of u with respect to the original letter. So we need to multiply by du dx. Okay, and then the u was still, let me just put it in parentheses, was in blue. And so then that's going to be it. Let's just sub everything back in. So our dy dx is 2, and then u is 2x plus 1, and then du dx is also a 2 there. And then at this point, we would probably just multiply the 2 and the 2, because those are just regular old coefficients, regular old constants that would multiply. And we would get dy dx is 4, 2x plus 1. And you could distribute the 4 if you want, but this is good because it's factored. Okay, so that's how we use the chain rule. Okay, so we just set something as u, and then from there, we set it up like this. You could do it in different ways. Again, I usually like the u and du dx, but we can show another way too in the next types of problems. Okay, but anyway, also with this, let's say it said check your answer by using a different method. Well, let's go ahead and state, well, we know that 2x plus 1 getting squared is 2x plus 1 times itself. I'm going to go ahead and FOIL all that. So we would get 4x squared. We'd have 2x and another 2x is 4x, and 1 and 1 would be 1. And then when we do this derivative, dy dx would be 2 would multiply the 4 to get 8, and then x is attached, and then plus 4 is left over. And notice if you were to factor a 4, it is this. It is the same thing. Okay, so it just lets you know. So sometimes you can check your answer if using some other method. Right, well, our next batch of problems, we can't really check using a different method. These ones, we have to use the chain rule. All right, so on number 1 here, let's first just go ahead and rewrite it as x squared plus 5 to the 1/2 power. Okay, and pretty much our pattern for the chain rule is whatever is in parentheses raised to a power is probably our u. I'm going to put that a little bit to the side, so just the x squared plus 5 is our u. And then I'm going to use the derivative of it. So du dx would be just 2x. So the derivative of u with respect to x is just 2x. And then that way I can go back to my original equation and state that y is, in the blue parentheses I said is u, and it's still raised to the half power. Well, if it's raised to the half power like this, now again it is just the power rule. So to do this derivative, I would have the dy dx, half power moves to the front, and then we still have u, minus 1 from that power would be negative 1/2. And then just if we change the letter, again, we just make sure to multiply by the derivative of u with respect to x at the end of it all. And so then we'll plug all of this in. So I kind of ran out of room. I'm going to put it right here. We have dy dx is 1/2. U was the x squared plus 5. And then it's raised to the negative 1/2 power. And then the du dx is just 2x. Okay, and then typically we would want to simplify the constants. They often will have some type of multiplication going on. So 2 times 1/2, the 2's, the 2's would just cancel each other out there. So we have dy dx. So one more time, I got to put my arrow here. My dy dx is, okay, so the 2 and the 2 just cancel. This red x we would probably put first, so the order doesn't matter that much. And there we go. And that's using a negative half power. If we needed to, we could change it back into a square root. It would go in the denominator, but for now I'm just going to leave it just like that. Okay, so that's how we can break down using the chain rule. Okay, so let's see a few other problems. Well, like the previous one, again, this is kind of our pattern for chain rule. If we see some expression raised to a power, then that expression is usually our u. So it's x squared plus 2x plus 3 is our u. And then once we have our u, we can find its derivative. Now, some like to just do like u prime, just to show a mix. So this is the same as du dx if you'd rather use that. But I'm going to just say u prime this time just to show a slight difference. And this is 2x plus 2. So it's still just the derivative like that. And then at this point, I would want to rewrite my f of x using that u. So it's f of x equals u to the 0.17. And then now, again, it's just the regular old power rule. So our f prime of x, the 0.17 would come to the front. Then we'd still have u. And then our power on the u, we would have minus 1 from that power. The u, hold on, let me make that u look like u. It looked like w. There. Okay, and then we would do minus 1 from this power like normal. So that would be negative 0.83, 0.83 like that. And then we just have to make sure, hey, just don't forget this in the red, multiply by u prime at the end of it all. And that's why I like to, once you set your u, just get your u prime or your du dx or whatever immediately. And then that way, especially if you use colors like this, you'll see this bright red thing. It's like, well, this I need to use this. So a common mistake is forgetting this u prime, but don't. If you see you've used something in the past, well, it probably needs to be used again in the future at some point. Okay, but now I can just plug everything in. So I have f prime of x is 0.17. U was the x squared plus 2x plus 3 to the negative 0.83, and then the u prime was the 2x plus 2. Okay, and on a problem like this, I think this would be okay. You could change some things around if you want, but I think that's it. That looks fine to me. Okay, so let's do a couple others. All right, on this one, we see we've got 4 over the 5th root of this expression. Well, similar to what we would have done back in the past, we usually don't like to see radicals. So we should rewrite this. I'm going to write it as 4. Now, we know that this is the 1/5 power, but it's in a denominator. So that means I should move it up to the numerator and just make it negative. So 3t to the 7 plus 8t cubed minus t plus 6. Again, it was to the 1/5 power, but I'm moving it up. So it should be negative 1/5 power. Okay, so there's that. And then, well, again, if you want to go ahead, pause and see if you can do it yourself, it is looking like this should be our u. The big expression raised to the power is usually the u. So we have u is 3t to the 7 plus 8t cubed minus t plus 6. And then once I decide on my u, I instantly need to find its derivative. I'm going to use du dt. So the t's on the right, so it's the derivative of u with respect to t. And then we just can go through this and do our power rule. It's 21 t to the 6 plus 24 t squared minus 1. And that's it. The derivative of 6 would be 0. Okay, so there's my work there. And then now I can go back to my original equation and rewrite it as g of t equals 4 u to the negative 1/5. Okay, so the u got subbed out. And then now I can use my power rule again. So it's g prime of t is equal to, all right, the power rule tells me the negative 1/5 would times the 4. So I'd have negative 4/5. And then the u still there. I need to minus 1 from that negative 1/5. If I minus 1 from that, it would be negative 6/5. And then I just have to remind myself, hey, you changed the letter, it went from t to u, so make sure to multiply by the derivative of u with respect to that t. And then now I would plug everything in. So we have g prime of t equals negative 4/5 u, which is 3t to the 7 plus 8t to the 3rd minus t plus 6, all to the negative 6/5. And then the du dt is that expression, the trinomial, 21 t to the 6 plus 24t squared minus 1. And then this, again, looks fine to me. Kind of the more complicated they get, the less chance there is that there would be simplifying. So this is good. If they said, hey, no negative powers, then we could eventually rewrite it as a radical. But I'm going to say this, I think, is just fine. So that is our final answer, all done. Okay, well, let's get one more in. Okay, so on number 4, we have 9y cubed times y squared plus 5y to the 9/5. And saying these out loud like that could help with recognizing that I do have a product. This is a product, 9y cubed times y squared plus 5y to the 9/5. So that means I got to use the product rule. Okay, so with our product rule, well, I also know, kind of looking at it, the right side would require the chain rule. Usually with the chain rule, we use u. You can change the letter, though, if you want to. Our product rule, we can use whatever letters we want to use. Let's use our u and v to set up our product rule. So remember our product rule, so this is q of y. I'm just going to say, hey, this in the blue is u, and this in the red is v. So all of that is v, and then I know, well, q of y is u times v. And then the product rule tells us, well, let's set it up, q prime of y. The way I use the product rule, I just write those letters and then put a plus in between. So I just write them twice, and then I go back and say, hey, I should alternate my primes. So u prime v plus uv prime. All right, and then now I would want to start plugging some of these in, or the ones I can. So let's see. So I'm going to start plugging things in if I can, and then put a pause if I can't. So u prime, so the u's in blue. So u prime, I can do that without any scratch work. So the 3 would times the 9. So we have 27 y squared. So that's u prime. And then v is just going to be rewritten. So we have y squared plus 5y to the 9/5. And then we have our plus. And then we have our u, which I could just copy. That's fine, 9y cubed. And then we have our v. Okay, so the v prime. So the v prime is a little bit of an issue. Okay, so the way I'm setting this up, so we've got our v. Let's do it in red here. So the v is y squared plus 5y to the 9/5. Okay, well this requires the chain rule. And I've already used the letter u. I'm currently using the letter v. So typically we just kind of keep going in alphabetical order. Next letter that we would probably use is w. So I'm going to say this right here. that's what w is going to be. So y squared plus 5y. So that way I can do the chain rule. So this one requires the chain rule because it's an expression raised to a power. So whenever you have an expression raised to a power, it's the chain rule. And then, well, as soon as you find your w, so this time it's w instead of u, well, still find the derivative. So it would be dw dy, which is 2y plus 5 as its derivative. Okay, so going back to my v expression, I have v is equal to, I'm saying this whole thing is w, and then it's raised to the 9/5. And then that way I can do my v prime. V prime is, well, power rule, 9/5 comes to the front. The w is still w for now. Minus 1 from that power would be 4/5 eventually. So 9/5 minus 5/5 is 4/5. And then we just have to times it by the derivative of our letter, the w, by, with respect to the letter of our original expression, the y. So it looks like this. Okay, and then all I'm going to do, so it kind of goes right into this next step. This w and this dw dy, I'm going to plug in so that it's in those parentheses. So it is, I'm going to put it right here, 9/5. W is the w right here, the y squared plus 5y raised to the 4/5. And then the dw dy is right there, the purple, the 2y plus 5. There it all is. Okay, so if there's a product rule still, we still have to do that. Sometimes we'll have the chain rule involved with it. Okay, so the other rule still applies. So same deal with the quotient rule. If you have to use the quotient rule, that's fine. You might need to use also the chain rule in some of these problems at the same time. Okay, well, anyway, now that it's all, we plugged it all in, we did the derivative, and then now it's simplify however way possible. Well, this first term is looking fine because that 9/5 power is not going to allow anything to distribute. So it's just going to look like this. And then in our other expression, there are some constants that would multiply. So the 9 and the 9/5, that would multiply. So we have positive plus, well, it is 9 over 1 if needed. 9 times 9 is 81. 1 times 5 is 5. So it's 81/5. And then I'm going to write the y cubed. And then let's do the purple one second. The 2y plus 5. And then finally this y squared plus 5y to the 4/5, like that. Okay, so and this could be an answer. I am going to box it. However, they often look to factor in these scenarios. Okay, so we're going to continue trying to factor. Okay, so all I want to do is look at what I have that would be in common with our variable expressions. And I can see that I've got a y squared and a y cubed. So in common with those two is y squared. So I'm going to take a y squared out. So it's whatever the smaller powered one is. And then also notice that this binomial expression is involved in both as well. Okay, however, it's just different powers. Well, it's the same rule for factoring out variable expressions. You just take out the one that has the smaller power. So we would take out y squared plus 5y to the 4/5. And then from here, we'll just look to see what needs adjustment. Okay, so I factored out a couple things, and then it looks like I'm left with a 27. This y squared was taken out entirely. This in the pink highlight, I took 4/5 of the power away from 9/5. So 9/5 minus 4/5 would be 5/5, which is the first power. So I'm going to write that. I'm going to show it's 5/5, but that would become 1. So the 9/5 and minus 4/5 is 5/5. And again, you could check if you distribute this back in, 4/5 and 5/5 adds up to 9/5. Okay, and then we have plus 81/5, y cubed had a y squared taken from it, so that means we're left with a single y. 2y plus 5 is still there, like that. Okay, and the reason that we might want to do this is because, well, this inside the bracket can continue simplifying. All right, so let's show one other, or hopefully it's one other step. So I've got our regular, there's our expression so far. Okay, and what I'm going to do, let's change this to just parentheses because the bracket, well, that's a personal thing. You could leave it as a bracket. But what we have, so the 5/5 is really just the first power. So that means this first power, this binomial is all we had to write. We don't need to write 5/5. We could just write y squared plus 5y, which means this 27 can distribute. So remember that you can distribute when the binomial is to the first power, but we would not be able to distribute any other time. Okay, so let me just add that little note up here. So you can distribute when you have something times, let's write it as just all letters. So this you can distribute, AB plus AC. However, so that's if there's, so only when that's a power of 1. If it's any other power, we can't distribute. No distributing. If it's A times B plus C to some power, so no distributing if P is something other than 1. Okay, so if it's anything else than 1, then this cannot distribute because, again, the power would tell us that's what's needed to be done first in the order of operations, and then afterwards we can multiply. Okay, so be careful of that. So we can't distribute. So like in this problem, like the negative 4/5, I could not distribute to these 4 terms. That would be bad because of the power there. Okay, well, anyway, this one is 5/5, which means it's a power of 1, which means I can distribute. So that is 27y squared. And then 135y, and then the 81y here, this would be able to distribute because, again, the power on that binomial is 1. So we'd have plus 81 times 2 is 162 over 5, and then y is squared still. And then 81/5 y times 5. This 5 down below would cancel with that 5 when we multiply, and it would be positive 81y, like that. Okay, and so we're pretty much there. I'm gonna squeeze it into here. So our q prime of y. So this y squared is good. The y squared plus 5y raised to the 4/5 is good. Inside here, there's like terms that combine. So 27y squared plus 162/5 y squared combine. Okay, so it looks like I would need a common denominator. We could use a calculator when we can. So let's go ahead and do that. Okay, so let me do that. And if you want to just move forward, I mean, you don't have to wait for me. You could do all this too. Okay, so Desmos. I'm gonna use Desmos Scientific actually. Okay, so I just want to plug that in. So I'm doing 27 plus 162 divided by 5, and it's that as a decimal. Let's leave it as a fraction. 297/5, and then we'll attach the y squared. Oop, that's still the highlighter. And then the y terms also combine. So we have plus 135 plus 81. Well, I already have the calculator out. Might as well. 135 plus 81, 216. Okay, and then attach the y to it, 216y. Okay, and so this is a factored answer. And in fact, you could factor more. This y. Okay, so let's do this proper one last step. This y is in common, so that means I could take it out. If I take that y out, it would multiply with this y squared. Okay, so one final step, q prime of y is, okay, so we say if we take out one of these y's, it would multiply with the y squared to give us y cubed. And then we have y squared plus 5y to the 4/5 still. And then parentheses 297/5. And then we took a y out of the y squared, so it'd be a y there. And then plus just 2/16. There you go. So real small in the corner. So sorry about this. Okay, so notice, so this could have been fine, but if they say factor, notice you have to do a few extra steps to get it all the way done. All right. Well, anyway, hopefully you don't have to do this too often with the factoring, but it's still nice to know. All right, so that is it. If you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.